Omkar sir is admitted?
Yes, sir. एक मिनट चेक करूं. हाँ सर, admitted.
गिरीश तेरे सर make Omkar sir co-host.
Yes, sir.
Anand sir, can you check it with Ashutosh sir?
Yes, sir, definitely, sir. Sir, okay, sir. हाँ sir, हाँ. Okay, sir. Okay. Sir, for time being, we can start with Rajan Padil, sir. He is joining in a very short time.
Anand, please wait, because joining him is must.
Yeah.
First.
Yeah, it is very must. Research person is must.
Session speaker, first of all, let him join. Ashutosh Tripathi has joined now. Sir, can you make him co-host? Ashutosh Tripathi.
Done, sir. Done. Go.
Ashutosh Tripathi, sir, can we check your audio and video?
Hello, am I audible now?
Ashutosh, sir, can we check your audio and video?
Hello.
Yes, hello sir. Hi.
हाँ सर थोड़ा सा वॉल्यूम अपना थोड़ा सा बढ़ाइए करके सर. आशुतोष सर. हाँ सर.
Yes sir.
अभी आ रही है?
Yes sir.
Okay.
Can we check your video, sir?
It is on.
Sir, you're audible. Just little bit increase your audio. Hello.
Okay. So now it's audible.
Yes, sir. It's very much audible.
Okay, fine.
Over to you, Radhika Desai.
So should I start?
Initiate the program. Yeah, 3 o'clock. It's
Thank
already.
you.
Yes.
Yes. Thank you. Hello all. This is Radhika Desai, Assistant Professor on behalf of Department of IT Thakur College of Science and Commerce, welcoming you all to the International Infothon Conclave 2K20, organized by IQAC and Department of Information Technology. First of all, let me take the honor of welcoming our session guest, Dr. Rajendra Patil sir, our dear participants, Vice Principal sir, Conclave Convener, Dr. S.D. Asgekar sir, and Vineet Vaidya sir, Deputy Coordinator, IQAC. Now, going with the spirit of a lockdown is not a full stop to learning. Making the most out of the current situation and gearing up ourselves for the changing times. Let's stay upbeat and immerse ourselves into the world of future IT. Machine learning algorithms, applications, and platforms are helping manufacturers find new business models, fine-tune product quality, and optimize manufacturing operations. It is an application of artificial intelligence that provides systems the ability to automatically learn with less or very less human intervention and improve the data using different data sets that is required. Now, I would like to request Dr. S.D. Asgekar sir, Vice Principal Science, TCSC, and our conclave convener for the welcome address. Over to you, sir.
Yeah, thank you, Radhika madam. Good afternoon. Thank you to each and every one of you for being here with Thakur College of Science and Commerce. We are pleased to welcome you all for this 3-day international conclave organized by IQAC and Department of Information Technology under our Skill and Talent Enhancement Program during the present lockdown situation due to COVID-19. The International Infothon Conclave is aimed to create awareness about increasing demand of information technology in the field of agriculture, finance, insurance, healthcare, entertainment, etc., and updating the recent development in the field of artificial intelligence, machine learning, robotics, data science, and semiconductor industry. So a very warm welcome to today's speaker for the session, Mr. Ashutosh Tripathi, who is Senior Data Scientist at Infineon Technology, and he is going to enlighten us on the topic machine learning, redefining the semiconductor industry. We are also privileged to have with us Dr. Rajendra Patil. Patil sir is expert in the field of machine learning and presently coordinator at Vidyalankar Institute of Information Technology. Thank you to Mr. Tripathi and Dr. Patil for being with Thakur College of Science and Commerce today for this particular session. On behalf of organizing committee, management of the Thakur College, and our principal, I myself welcome to each and everyone. If you have any questions or suggestions, clarifications, you can contact us in the chat box. Thank you very much and welcome to all of you for this particular international conclave. And I'm very sure there will be a good discussion in this particular session, and all participants will be going to take some new ideas, informations, and the update in the field of information technology. Over to Radhika Desai, madam. Thank you.
Thank you, sir. Thank you so much. Now, I would like to welcome Dr. Vineet Vaidya sir, Deputy Coordinator, IQAC, Thakur College of Science and Commerce, to share a few words. Over to you, sir.
Thank you so much, Radhika madam. Mr. Ashutosh Tripathi, who is the speaker for the day, Dr. Rajendra Patil, the guest for the day, all the delegates, all the resource persons. It is my great privilege and pleasure to talk to you in the capacity of the Deputy Coordinator of Thakur College of Science and Commerce for IQAC. The college has begun in the year 1997, that is the degree college beginning, which was been followed in 1999 with the science section, and we completed our first cycle of NAC accreditation in the year 2004. Soon after 1 year, we formulated our IQSC in 2005, and till that day, we are continuing with various kinds of projects and various kinds of quality initiatives through IQSC in our college. The college has completed 3 cycles of NAC, with the latest 3rd cycle, which has been completed in 2016 with A grade. And with this brief introduction, this is the initiative which has been taken by IQAC under the program of STEPS, that is the skill enhancement and talent enhancement courses, which we are trying to introduce and we are going ahead with. So with these few words regarding the IQAC, I would like to conclude, and I wish all the success for this particular session of machine learning. Thank you so much, every one of you. Over to Radhika madam. Thank you.
Thank you. Thank you so much. Hereby welcoming our session guest, Dr. Rajendra Patil sir, Coordinator, Department of Information Technology, Vidyalankar Institute of IT, BOS member and Chairman of MSCIT Examination, University of Mumbai. Having over 20 years of experience in academic field, his area of research is AI, ML, database, data analytics, deep learning, and some other related fields. I hereby invite Dr. Rajendra Patil sir to please come forward and give the inaugural talk. Thank you, sir.
Thank you, madam. It is an honor and to be the part of such an Infothon, which has been organized with one of our active member, Dr. Santosh Singh, the management of the Thakur College, Principal Dr. Chatterjee. So it is really it is an honor to be again to be associated with this international conference, which has been conducted in the online mode, showing the new directions and dimensions to the field. As everyone knows that machine learning, it is one of the upcoming areas which is basically existing in different flavors. We can see the machine learning which appears in technology, means hardware form, which is applicable to the various types of smart devices. And really the organizing committee, they had really picked up one of the area which is really in demand again with research as well as the industrial aspects. We can find the different types of hardwares where now machine learning has been employed and it has been applied in all the different areas. So take an example right from the smart processors which are coming, the next generation processors we are talking about, the semiconductors as the theme is there. Even at the same time, through this particular conference, this will give the exchange of ideas from the experts as we have today, Mr. The chief guest, Mr. Tripathi sir. So Mr. Ashutosh Tripathi sir. So I again appeal, or on behalf of the Mumbai University also, I would like to just mention here that this is a great initiative which is taken, and for researchers, for developers, for learners, even the students, for all participants, really this is going to be the good event where they can learn, they will have the exchange of ideas through this particular platform. At the same time, as you know that machine learning, IoT, AI, all these has become the buzzwords of the industries. And through this conference, it is an opportunity for everyone to have the exchange of knowledge, exchange of ideas, what we have, and this will really give us the new opportunity to have a new thought regarding the subject. Those are the beginners and those are the experience, even they can contribute through this particular conference. So I congratulate the organizing members, the committee members, management of Thakur College for having this Infothon for all of us. Thank you.
Thank you, sir. Gearing up to an informative session, I would like all our participants to support us by following certain guidelines during the session. Please keep your video mode off. Please post some questions related to the session on the Zoom chat box. Of course, due to the limited time constraint, we'll only be able to take certain questions. And please do fill the feedback form, whose link will be posted on the Zoom chat box soon. Now, taking the opportunity and without further ado, hereby taking the session ahead, I would like to welcome our session expert, Mr. Ashutosh Tripathi. Having 8 years of experience in semiconductor domain, he has been working in latest technologies like computer vision, natural language processing, and reinforcement learning. He has also worked in full stack software development and currently a senior scientist, a data scientist in Infineon technology. Welcome, sir. We welcome you to the session, and please do overtake the session, sir.
Thank you, Radhika ma'am. So first of all, let me check. Am I audible properly?
Yes,
Yes,
sir.
sir.
Yes.
Okay.
Yes, you're audible.
Okay, fine. So I would like to take this opportunity to thank you all, organizing committee, all the management members, and a special thanks to Mr. Anand sir, who has invited me. So he has contacted me through LinkedIn. So very much thank you for you. And so without wasting much time on this, so let me start the session because we already 15 minutes past 3. So I will share my screen and then start.
It's visible, sir.
Okay, thank you. Thank you for informing. So, okay. So my talk is mainly based on the focus will be the semiconductor industry and how AI is being utilized there and what is the impact on that. So let me start with the agenda first. So as Patil sir has already mentioned, like there is a lot of buzzword with respect to AI, ML, DL, and DS. So I will start with the defining what is AI, what is ML, and all these buzzwords, terminology. And then I will jump to machine learning overview. So here I will define what are the different types of machine learning technologies mostly used, and then a typical life cycle of ML model. And then I will, after giving this basic introductory talk, then I will just tell you like what are the trends in semiconductor and what is the adaptability of AI and what are the expectations from semiconductor industry, from AI and all those things. And then I will also talk about what are the main AI technology verticals which are there to help semiconductor market to improvise their optimization process, manufacturing and all those things. And then I am going to pick one important area, that is digital image processing, that comes under computer vision. So there I'll take some time and I will explain what is the CNN architecture and how it is helpful in one of the use case, that is a wafer defect identification in semiconductor industry. So with that agenda, let me start with first, what is AI, ML, DL, and DS? So most frequently used buzzword. So what is AI? So see, AI is nothing but the program with the ability to learn and reason like human. So when I say this line, what does this mean? So let me take an example. So suppose we have a trained machine on all the AI related topics. So it becomes a kind of question answer chatbot. So it is able to answer all the AI related questions. So that is one robot kind of thing. And also simultaneously, we have one AI expert. Okay. So now suppose we have certain questions and we are going to ask from that AI expert and he has given certain correct answers. And now we are going with same question set to that trained robot model. And now when he's answering, if he's able to meet our expectations, means if he's answering all the questions correctly and almost similar what that AI expert has answered, then it means that a robot is behaving like an artificial intelligent machine. So that's how we can understand and define artificial intelligence. And then next branch under artificial intelligence, that is nothing but the machine learning. So what machine learning is all about, how we differentiate it. So it is nothing but the algorithms with the ability to learn without being explicitly programmed. So this is very high level line I'm writing here, right? So what it is telling. So machine learning has a different branches like predictive analytics, statistical modeling, forecasting. So let me take one example here as well to define the machine learning. So see what happens. So we have in mathematics, we have certain formula defined. For example, if you want to sum two numbers, then we do a plus b is equal to c. C is the output. So how machine learning will detect the sum of two numbers? So what happens? We will feed many numbers like certain A values, certain B values, and their respective sum in C. Okay, and we train the model, and then as an outcome, we expect the summation of these two products. Then a question may arise. Now we have already summation formula defined. Then why we need this machine learning to predict the sum, to come up with the sum, right? So the reason here is like there are certain scenarios where a well-defined formula is not exist. Okay, for all real world problem, we cannot have an exact mathematical formula defined, right? So that's where machine learning comes into picture. So it try to learn the pattern behavior, and based on that, it predict the output. Okay, so that's what machine learning do. And then next come the another branch, that is the deep learning. So when we have all the predictive power, statistical power, forecasting, everything in ML defined, what is this deep learning doing here? Okay, so what happens in machine learning? We are dealing with mainly structured data, right? But as we are doing the technology advancement, so we are seeing like a lot of data is coming. Okay, lot of unstructured data. With unstructured data, like I mean, like lot of images are there, raw text is there. Okay, so a training model in that much data, it requires lot of computation power, and lot of layers we need to train, means lot of iteration of training we need to do. So that's where deep learning comes into picture. So in recent years, we have done some advancement on the computation power, as well as we have lot of data. So that's where we use deep learning to train multiple layers and come up with the outcome. So that's the only difference between deep learning and ML. Right. And of course, we do some see in machine learning, when we do feature engineering, we do it manually. Okay, some data scientist expert, machine learning expert, he writes some programs, some techniques he define, and he come up with feature engineering. But in deep learning, we don't need to do this explicitly. Okay, so this all handled automatically. That's the advancement. So that's what we can say, like kind of machine learning work is automated with the help of deep learning. So that's why we have kept it under machine learning. Then next is data science. So data science is I can say is the combination of artificial intelligence, machine learning, deep learning, and of course certain different techniques. So it's nothing but just coming up with certain insights from the data. So where data science helps. So we have see in our day-to-day life, like if we are a part of management, then we need to take a lot of important decisions, right? So what happens in past, like we take the decision based on our experience. But now what happens, this data-driven insights help us to take a right decision, or I can say with the 90% accuracy, right? So that's where this data helps basically. That's how I can define the data science is nothing but just generating the insight from the raw data. So that's also we study in information technology, like converting the raw data to information. So that's very important, right? So that's data science all about. So, and what are the different, topics or knowledge domains we study under data science? Like we have statistics, and of course we need domain knowledge to come up with some insight. Suppose I'm gonna talk about semiconductor, right? And if I don't have much knowledge on how semiconductor industry works, what are the different terminology, what chip means, what is the integrated circuit means, then coming up with insight is very difficult, right? We cannot ask the right set of questions from the data. So that's where domain knowledge is very important. And of course, we need certain programming skills. So mainly we are doing this data science work in Python and R. So same thing I have written here. And then of course, some statistics, like in last 10 years, like 80% of the whole world data is generated. Just imagine, right? In just 10 years, almost all the 80% data is generated, right? And of course, simultaneously, we have done the advancement in computation. So that's where, nowadays we are talking about all these buzzwords and all these technologies. So that's the main reason. Now, with this, let me go through like what is the machine learning overview. So under machine learning, we study the supervised learning, then unsupervised learning. Then of course, we have a third branch called reinforcement learning. So what are the different problem sets we understand, we study under supervised learning? Two. That is a classification problem and regression problem. So what is a classification? So classification, it's come under the predictive modeling bucket. So where we want to identify the certain classes. So for example, we have a patient information. So we want to identify whether a person has having a diabetes or not. So how we will do this? So we will store certain medical related information like his BMI index value, his blood pressure value, his glucose level. With all those information, we build the model and predict. So it's nothing but categorizing the certain classes. So that comes under classification problem. And then we have another type of problem, that is a regression. So what we do here? So regression is nothing but predicting the continuous value. For example, we are interested in knowing the price of a particular entity, particular land after 10 years. Okay, then in this kind of problem, we go with regression. So I have placed one example of each of them and what are the important algorithms are used. So that I will explain in next slide. So let me first introduce you to what is the unsupervised learning. So unsupervised learning is nothing but like when we have a completely raw data, we don't have any labeling defined, because in supervised learning, we have mostly data come up with a label defined, but unsupervised learning, we don't have label defined. So here we understand two types of problem. One is clustering, one is association. So what is clustering? So just imagine, so we have a set of balloons, okay, and they are in different color, they are in different shape, they are in different sizes, maybe, right? And they are all lying within one room. And now we have very small kid, okay, we have kept him inside that room, and so what he will do, he don't know anything about balloon, he don't know anything about coloring, but what basic feature he can identify? He can immediately pick the, okay, there are some are smaller, some are bigger, right, based on his understanding on that particular level. Okay, so that is the one way clustering works. Based on different features, we group the items. So with this kid, how he is grouping based on different sizes. Someone who has understanding of the color, how color works, okay, then he can group based on different colors. Some other person who has understanding of different shapes, then he may group based on different shapes, right? So these are the different techniques how clustering works. And then next problem is like association. So what happens here, like so association works by understanding the different patterns and behaviors. Like for example, you are going to some grocery store and you are buying certain product. Okay, so most of the time it happens like there are certain items you buy together, right? Suppose you are buying a baby powder, then most likely you will also buy a diaper, right? Because you have a baby in the home, right? So diaper is a requirement. So that kind of behavior analysis we do in association. So that comes under unsupervised learning. Then we have third branch as reinforcement learning. So there we study two types of entities, object like agent and reward. So how reinforcement learning works? So you just imagine. So here you just imagine we are gonna train a robot the task is he has to climb the stairs. Okay, but these stairs, let's assume they have a different height of steps, right? They have different steps. They are not of the same height. So what happens? Agent. So here robot is work like agent, right? So he will try to take a step. So he don't know about the height, how much jump he has to take. So he will start with some random height. Okay, and he didn't reach the next step. So what he will do? He has two options: either increase the height or decrease the height. So, but he don't know whether he has to increase or decrease. So what he will do? Let's say he is decreasing the height, just random. Okay, but by decreasing the height, he is going far from the destination. So from the outcome, right? From the desired behavior. So in that way, so this is a negative behavior. Okay, so we'll mark this behavior as a negative one. Okay, this outcome is a negative. Then next time he will try to increase the height. Then he will reach one step nearer to that particular step where he want to climb. Right? So this is the positive behavior. So likewise, we identify many behavior and keep on adding, deleting. So and at the end we train it. So reinforcement learning, we cannot generalize. It's specific to particular problem, and we have to train the model for a specific problem. Whether we want to train the robot for climbing, whether we want to train the robot for walking, whether we want to train the robot for swimming even. Okay, so that kind of problem comes under reinforcement learning. Then of course, four type of problems that we have, like optimization problem. So this is a very common problem. Like we have already some set of defined step, like some algorithms, some patterns we are following since long time. Like for example, let me take a chip development example. In chip designing, we follow some set of 6 steps. Okay, in that we have certain of floor planning, like a PCB printed circuit board designing. Okay, so we define the routing algorithm. So we have some standard definitions how we define the routing algorithm. But there are still, but what happens at there, sometimes congestion happens. So this congestion use case I will define it later, but for time being, this slide just isn't some congestion happens. So what happens? They again reiterate. So here there is a need of optimization. We can optimize the process. Okay. So there in these kind of scenarios, we they go with optimization problem. And then fourth one is like what there are certain mathematical methods to be used and very helpful, like the linear algebra and calculus. Mathematics is very vast. We don't need to understand, go through every topic, but with respect to data science, machine learning, these two topics are very important, linear algebra and calculus. Okay. So with that, let me let me go in more detail with what is supervised classification regression. Next slide. So like see. So as I was describing about the diabetes patient information, so this is how classification problem works. So we have a patient data, and then we train on certain model. So what this model will be like, there are so I have already mentioned, if you see in the down, like there are certain algorithm like logistic regression, nav-based, k-nearest, decision tree, ensemble methods, random forest, support vector machine, that is well known as SVM. So I'm not going to describe each and every algorithm because we have very short span of time, but just let me give you some overview. Like when we say like training the model, so we choose one of the algorithm which is best suited for that particular use case, and then we train. And then we come up with an outcome like whether that person has diabetes or not diabetes, right? So these are the two different classes we are classifying. So that's how classification algorithm works. And next is regression. Okay, so how regression? I given you one example of predicting the house price for next 10 years. Okay, let me take another example. So when we are in automotive industry and we are going to design a vehicle or something, okay, some vehicle or motorbike or anything, okay, so then we are going to test the brake system. Okay, so when we are applying a brake, so we want to identify from current point how far our motorbike going to stop. Okay, so let me ask you, so what are the different factors governing apart from that braking system, which will determine the stopping distance? So stopping distance is nothing but when we apply the brake, how far from the current point our vehicle will stop. That is the stopping distance. Okay, so what are the some factors like surface resistance? Okay, so that is one factor. If it is raining, then resistance may be less. Okay, it may stop little longer. Okay, and then there are some path holes in the surface. So there are many driving factors which affects this. Okay, so we need to test this braking system in different scenario. Okay, so those are the different variables or features we take into account while training the system. Okay, training the model. So now suppose we have trained. Okay, so how it is gonna work? So and one more important feature like current speed of the vehicle. Okay, so with what speed it is going in miles per hour. So after training the model, we have come up with the best fit line. So there is a definition of best fit line, like here you see all the dots. So these are the different data items and how we draw the best fit line. So our idea is to reduce the error. So what are the error like? So in statistical terminology, we do the projection on the line and then we minimize the distance from each data point. So that's how our best fit line comes. So don't get confused. It is not the line which passes with most number of the data points. It is the line which minimizes the vertical distance from all the data points. So that's how we draw the best fit line. Now, so in a horizontal x-axis, we have a speed in miles per hour, that is 5, 10, 15, 20, 25. Okay. So for example, just forget about 25. We have data till 20. Okay. And the stopping distance in feet. And now we have drawn this best fit line. And now we want to identify what would be the stopping distance when we are running with the 25 miles per hour speed. So that we can easily identify, we can just project this point on this best fit line and we can identify. So that's why with this green arrow, I have tried to show you there is some point here, maybe assume some 13. So if our speed is 13 miles per hour, so what will be the stopping distance? Just project and you'll get the stopping distance. So that's the whole idea. We are predicting the continuous value. It will be some number, some real value. Okay, not the classification problem. So that's the difference between classification and regression. And of course, we have some important algorithm how regression works, like linear regression, multiple linear regression, decision tree also can be used for regression as well, random forest as well for regression problem. Okay. So now let me define what is the clustering. So suppose you have a bucket of items which have different types of items and we want to cluster. So clusters are nothing but the groups of same data items. So this is how we can. Similar, I explained the example of balloon. We can do like by coloring, by shape, by size, and we can cluster them. So I'm not going to explain again. So it's a similar feature, like similar concept. So how clustering works, like find elements which are similar, finding areas in a space where data is concentrated. And of course, this is very important. What you select is what you get. What this means? See, if we are doing the clustering based on the color, we'll get the clusters based on different color items, right? Like green and red is orange. Okay, so red is orange, kind of similar, and then blue is, then gray is. And of course, if our definition is different, we want to cluster based on the shape, then some smaller item, then a bigger item like that. Okay, so that's how clustering works. What are the important algorithms? We have like K-means clustering, fuzzy C-means, expectation maximization, and then hierarchical clustering. Then of course, what are the important applications? So we use clustering in recommendation systems. So what is the recommendation system? Suppose we are going to e-commerce site and we are buying certain product. Okay. Then in backend, they run this recommendation system algorithm and they suggest us like if people is buying this kind of product, okay, then there are some similar products which he might also be interested. He can also buy, right? So that is also an example of clustering. And of course, little bit, it is also related with association rule mining that I'm going to explain next slide. And then market segmentation, social network analysis, search result grouping, image segmentation. Also, we have anomaly detection. Okay. So now, what is association? So as I was telling about, like when we go to a grocery store, so we buy certain items. Okay. So in left side table, you see like these are the transaction ID in first column and then items. In one transaction means one transaction represents the individual person. Like I'm going to the market, I'm buying bread and milk. A person two is going to the market, he's buying bread, diaper, beer, egg. So that will count as a transaction two. So similarly, there are 5 persons who are going to the grocery store and they're buying these items. Okay. So in database, how this information will be stored? Of course, we are not going to store in like bread, milk, and all those. We'll assign some ID. Like, okay. And then in transaction, so each transaction, so in a vertical axis, we have a transaction ID like T1, T2, T3, and horizontal, we have an item name. 0 means in transaction T1, person has not bought this, and 1 means in transaction T1, person has bought bread. This is how we store. So that's not important how we are storing. Important to understand the concept. Okay. So the concept says, so people who buy diapers are likely to buy a baby powder. How I am telling this? By only looking into this small table. So this small table cannot tell if people are buying diapers, they will also buy baby powder. But yes, if we have many information of similar transactions, okay, like historical data, 1 GB, 2 GB, okay, then with all that data items, we train our model, then we can come up with these kind of insights. Like if people is buying diapers, they will most likely buy baby powder. So that's the basic concepts that comes under association rule mining. So these are the statements about relations among features. Features are nothing but the attribute across elements that are tuples, nothing but the rows. Okay? And we use a transaction item set data model for storing this. So what are the important use cases, or I would say applications beyond market basket analysis? So above in table, I have explained the market basket, but what else, what other application we have, like people who visit web page X are likely to visit web page Y. Right? So that's also important use case. And nodes which run as a web server are likely to run on Linux. So that's also kind of feature pattern we are identifying. And people who have age group 30 to 40 and income greater than $100K are likely to own a home. So that's kind of insight we conclude from the data when we go through the data and generate some insight. So this is all about association rule mining. So then next, I will be explaining about the machine learning model flow, end-to-end life cycle of an ML model. So how we start? We start with data gathering. So data could be any format. It could be live streaming. It could be stored in Excel. It could be CSV. It could be a JSON structure. That is, a JSON is nothing but semi-structured. It will have a key value pair. And then once we have a data, of course, we need to do some exploratory data analysis. Okay. So what this all about? So in data analysis, what we do, we learn what are the different categories, what kind of data type, if they have any missing values, and all those exploratory data analysis we do here. And then comes the feature engineering. Next is feature selection, then machine learning model building. So I have explained all these here, like data gathering, what is all about, then data analysis, then what we do in data pre-processing. So what happens? Sometimes we generate data manually. Okay, we collect data from different sources and create an Excel. So what happens while generating data? We don't have, sometimes we don't get a particular value of a particular item and row. So we leave them empty. And sometimes there are chances, the human error, he forget to put that particular value there. Okay, so there are many various reasons and we don't have data there. Okay, so that is the step we deal in data pre-processing step. So there are many methods. So one basic, very basic, we simply remove that row. Okay, but by removing, what happens? We may lack enough data points. We may lose important information. Okay, so what could be the next idea? Next idea to fill that value. So how we gonna fill that value? So there are many ways. Like we can fill with the mean value of that particular column. Okay, mean value, median, mode. So there are different. So there are certain scenarios where we go with mean, with median for categorical, median when there are some outliers in the database, with mode when there are category in the data set, a categorical item, we fill it mode. Yeah. And the next step is like we do variable selection. So what happens in many times we have too many, like thousands or even more than that columns. And what they do actually, they behave like a noise. Like, okay, not all the features are important, so they will introduce some noise. So that is not good for our model building. Sometimes what happens, due to that our model start overfitting because it doesn't learn the pattern, but it starts learning exact data point. Okay, so that's the reason we need to do the feature engineering. So there are various methods for feature engineering, like we do principal component analysis. Okay, so there are many other methods which we apply here in feature selection. Okay, so then next step is like model building. So before model building, of course, we need to split our data in a train set, validation set, and testing set. So in train, so in model building, we choose one particular algorithm based on whether it's a classification problem or regression problem or forecasting problem. We selected one particular algorithm. Then we train the model on training data. Then we test the accuracy performance on validation data. If accuracy is okay, we go and deploy and then test on live data set, use that prediction accuracy. Or if it is not meeting the accuracy, what we do, we need to do the fine tuning. Then how we do fine tuning? So here, if you see in the figure, like in machine learning model, we have back arrows. So we need to redo the feature engineering. We can redo the feature selection. We can apply different set of hyperparameters. So what are the hyperparameters and what are the parameters? So parameters, what system or machine defines. But what hyperparameters? So they are nothing but for which there is no standard rule exists. So like we define the hyperparameter. Okay. So when I will be explaining the CNN, I will explain more about hyperparameter and what are the different hyperparameter with respect to CNN. So every machine learning algorithm have different set of hyperparameter. Okay. So now once we train the model, we tune it, and then we deploy. So that's cover the whole ML life cycle. So now this is the basic about machine learning and the different terminology. Now let me jump into the how it is impacting the semiconductor industry. So now, so I have put some research on this slide. So if you see this figure, like, so this research is done by Accenture Technology Board. So what they have done, they have collected the thoughts from the top executives from different market segments, like semiconductor, banking, software platforms, automotive, and there are many more. And they have found, like in semiconductor, it's majority of the top executives feel that AI adaptability is more significant than other sectors. So you see, there's 63% believes and understand the impact. Okay, so that, and then there are certain market opinion, like from Accenture Managing Director, Mr. Syed Alam, who is also leading its semiconductor practice globally. So what he says, like AI will be a major growth driver for the semiconductor industry in light of high manufacturing cost, growing complexity of chip development. And also he's saying, like, to capture this opportunity, chip makers should leverage AI technologies and partnerships to increase efficiency across their operations. So that's the market opinion. Market also think like AI is very much important in semiconductor as well as in other domains. So what are the different top trends in semiconductor? So like trend number 1 with respect to AI, that is the rise of artificial intelligence. Trend number 2, going smaller but stronger. Trend number 3, that like using analytics to optimize semiconductor process. What is all about? So how they have come up with these trends? Why artificial intelligence is so much important? Why that much hype? And what is meant by going smaller but stronger? And why we are telling like analytics can optimize the semiconductor process? So let me explain this in next slide. Okay, so this is also some study from market. Like so, see if you see the x-axis. So this is nothing but the size of the IC integrated circuit. Okay, so we have started from 65 nanometer and going towards 5 nanometer. Means we are going smaller and smaller day by day. Okay, but going smaller, this is not that easy, that is straightforward. If you see in the y-axis, see the design cost. See, even from going 7 nanometer to 5 nanometer, see the jump in cost. It's for 7 nanometers, total design cost is $297 million, and for 5 nanometer it is $542.2 million. See, there is a huge rise. Right? So that's the reason these semiconductor executives things like we should adapt AI and improvise or optimize our process. So there are a lot of, see, we can optimize our software process, we can optimize our validation step, we can optimize our verification, we can automate certain verification, certain validation steps, right? And even we can automate certain software techniques, right? So there are many area of research which we can do in semiconductor. A lot of potential is there. So now with all these, what are the semiconductor ideal expectations? If everything is going smoothly, perfectly fine. So they are expecting no repeated iterations, because in last slide you have already seen what is the cost of implementing the complete design of one chip, right? So if any iteration is repeated, it will directly impact the cost. Second point is tools should not return unexpected results. Same, it will also impact the cost. achieve predictability from the user's point of view. We need to understand in advance what is the requirement, what are the users expecting, and all those things. Use old design data to improve new designs, of course. We should learn from our past. It's the normal saying, right? So here also, if we have old design data, why not to learn from that design data to improve the process further and optimize the cost, right? So that's where we can apply. There are many areas we can apply AI there. Focus on reducing the design time, design effort, right? So this is all the ideal expectations. So with that, what is the solution? Machine learning will be a key piece for this. AI will be the key piece for this. Okay. So now, what are the different technology verticals used in semiconductors? So till now, I have only explained the machine learning algorithm. What are the different categories like supervised, unsupervised, and reinforcement learning. And there, I explained also about the deep learning. So now these are the advanced concepts directly belonging to deep learning, where we have unstructured data. So these three important verticals like natural language processing, computer vision, and of course the machine learning one. Okay. So now what comes under natural language processing? So it is a text processing technique to process raw and unstructured text to generate information. So what are the different use cases? We can generate Q&A bot, which I took an example while explaining what is AI. Sentiment analysis, we need to understand the sentiment in the market. We have a lot of user log gives a lot of feedback. So there also we can understand the ratings, right? And then we have document retrieval. So of course, if you see in Windows, we can search a document with respect to a name. But do you think you can search if you just know the content inside the document, but you don't remember the name, what you will do, how you will search, where it is lying? Right, and even though that becomes more important when you have lots of data generated every day. If you think about aviation industry, you can imagine how much data they are generating every second, every minute, right? So that's where these kind of techniques are important. Their data size is really very huge. So important libraries like NLTK, that is a natural language toolkit, and the current we also have the SPACY. So of course, these both do the similar task, but in particular scenarios, one has advantage over other. So I cannot say like one is more important than other. It's nothing like that. Both are important, but depends on the use cases. The next, I'll talk about computer vision. So computer vision, or CV, is a digital image processing technique where we apply different neural network architecture to process image and classify them. So what are the different use cases like with respect to semiconductor industry, like wafer defect identification? So what are the early prediction of congestions, and of course image to image generation. So what is this image to image generation? See, in most of the cases, sometimes we face the so till now I have only talked about like we have lots of data getting generated every day now, but this is not the only case. In certain situations, we don't have enough data also. Like if I talk about congestion prediction. So what is congestion? When we design the floor planning, so there we need to define the routings. So and at the end, we get the congestion. So so these kind of images, we don't have enough, right? So if we have only limited set of images, then how to train the model? That some limited set of images won't be enough for training. So that time image to image generation is very important. We just tweak those existing images, generate new images, and then we train the model. So important architecture used for computer vision is CNN, that is a convolutional neural network. So I will talk about this in detail. And then of course, we have some machine learning techniques also used for anomalies detection, predicting upcoming market trends, stock price forecasting, and all those. So these are the top AI verticals. I'm not going to be detail in all these three, but of course, I will touch computer vision in more detail, and I will explain the complete CNN architecture, including all the layers. Okay, so this is the congestion prediction, which I named twice or thrice in last slide. So here, if you see the left, so we have two things, like one is left side, one is right side. So left side is a traditional EDA approach. So if you see these bottom left images, like pre-route design and congestion map after routing. So there are some set of procedures, set of steps we use. So our designers use to come up with the routings. Okay, where to place the different connectors like inductors, capacitors, and registers, and different electronics component. Okay, so once they placed, they define the routing algorithm. At the end, they good to know, okay, there is a congestion. And then they need to repeat the steps. They need to follow many different other approaches. Okay, so this whole cycle is very costly, very time consuming, effort needed. Okay, a lot of things. So why not we applying machine learning techniques here to optimize this congestion prediction or early prediction of the congestion? If we are gonna follow this kind of routing algorithm, then this kind of congestion will happen. So that's what we see in right side. Sorry. So in congestion, like in the first image itself, we are predicting the congestion. And before going to the final routing floor planning image, we are predicting in advance and we are correcting it here itself instead of repeating the whole cycle again. So that's where we are optimizing the process. Okay, so this is one use case. Another is like wafer defect identification. So what are the wafer defect identification? So wafers are nothing but the product of the silicon. So they are used to design the chip, physical chip. So they live in manufacturing areas, fab basically. So what are the defects in wafer? So many times when we create the wafer, so what happens? Some glass particle comes and sit in wafers. Some dust particle comes. Okay, so they create some cracks, scratches in wafer images. And if we don't identify, or if you are not able to identify in early stages, then and we are building the product, you can again think about that design cycle cost. Design cycle cost. So what is the impact of that cost, right? This is too huge. So that's where identifying or classifying these wafers in a correct class, whether it is defective or not defective, it is very much important. And that's too early identification. It's not like once we are placed in the chip and then we are going to doing some analysis on chip level. No, we have to do it in very early life cycle. Okay, so what happens? So we start with many wafer images. Some are defective, some are not defective. We generate the train data. We apply CNN architecture, that is a convolutional neural network. We feed them, then we train, and we come up with a classification mechanism. So how this all things is happening, I'm gonna explain this. So this is the basic image classification. So what happens? Like for example, here along with wafer, we have some automobiles, bird images, ship images, and aeroplane. Okay, so what happens in traditional approach? Like one option is like we can do it manual classification. But for example, imagine you have thousands of images. Can you do this manual classification? No, totally no. Then we have some statistical techniques like distance matrix. So how distance matrix works? Like it works based on the similarity features. Like in categorical type of object, like string type object, we have Hamming distance concept, and other like we have cosine similarities and other distance metrics. But these also, they work, but they don't give good accuracy. So that's where comes convolutional neural network. It has proved its accuracy, and it gives very high accuracy in image classification. So for CNN to work, we need to feed those images. But you know, computer and all those machine learning algorithms, they don't work on string. They don't work on images. They only work on 0-1 bit numbers, right? Right. So that's where we need to convert the images to some pixels, right? We know images is nothing but a combination of different pixels. So you see here left side, there is a 7 digit 7. And if we convert it to the 28 grayscale image, then this is a grayscale image, okay, and we convert it to the pixel, then it will something look like the right side, okay. So it becomes the matrix of 28 rows and 28 columns, okay, with the pixel value ranging 0 to 55. And you closely look, it is making the 7 digit as 7, right? So we don't feed this image directly to our networks. However, we feed this data. These 28 cross 28 matrix we feed, and then we start training to different layers. So this is the first step we do. Okay, but but what are the challenges we come in feeding this data? So in previous digit we have just 28 cross 28, but in most of the cases this image size can really go bigger, right? So suppose an image is of the size 68 cross 3. So 3 is nothing but if we are considering all RGB. Okay. So the input feature dimension then becomes 12,288. Just multiply all these 3. Okay. In previous case, we can multiply 28 cross 28. So that will be the input feature dimension. And then now if we pass such a big, now still 12,288 features are still fine. We can apply feature engineering and all those things. But imagine if you have 720 cross 720 cross 3 size image, you can multiply and see the big number. Okay. So for this huge size, it's almost impossible or not easy, right? Because see, imagine about computational power, imagine about memory requirement, right? So these all are the challenges. So that's where convolutional neural network helps us. And of course, in today's world, the computational power has gone increased basically, right? So that's also helping. So that's how CNN has been designed. Okay. So this is the complete architecture. So in CNN, we have different layers. So of course, we feed the input images in terms of pixel matrix. Then we have a convolution layer. Then we have pooling layer. And then with this convolution and pooling, we do multiple iterations. That's how we define the different layers. We come up with the weights. And then we apply the final output layer, that is the classification layer. So what is the functioning of this convolution? What is the functioning of pooling layer? And how output layer works? Let me explain. Okay. So now the first layer is the convolution layer. So how it happens? Suppose you have an image that is the left side. Okay. So convolution layer is nothing but it helps you to identify the edges. And edges can be of two types. That is a vertical edge and horizontal edge. In vertical, see, you just see closely. So you see vertical spikes kind of thing, right? In vertical edge image. And then in horizontal, we have like a horizontal bar spikes, right? You can see horizontal lines. So this is the pattern. This is the thing identified by convolution layer. And as we have multiple convolution layer, so it will start identifying different features. So, but how this all happens? So for convolution layer, so in left side, you just see this is our image data converted into the pixel matrix, and then we define a filter. So what filter do? It convolve basically throughout the image and calculate the feature matrix. So feature matrix is nothing but the features like, so if you just imagine like this, you have a big image and in particular image, one particular area is of more important. There are some background noises which you want to neglect, right? So these are the different spots, areas within the image. So some you want to keep, or I can say some you want to give more focus, more priority, or some you want to neglect. Maybe you want to make it blur. So that's what filter do basically. So let me explain the working of filtering. See, so if you just see the light green one, so this was the original image, and then orange one, this was the filter. So now it is starting convolving over the image. So it is a 3x3 filter, and the big ones are nothing but the pixels of values like 0, 1, 1, 0, 1, and the suffixes are the filter value 1, 0, 1. Like if you see in the previous image, this is the filter, right? So now what happens? We just do the multiplication cell-wise 1 cross 1 plus 1 cross 0 plus 1 cross 1. Like this, we do multiply and add. Then it will sum up to 4. So here 1 plus 0 plus 1 plus 0 plus 1, 0, 0, 0 plus 1. So there are only 4, right? So it is summing up to 4. So likewise, we convolve this filter to the whole image. So now we are convolving in the next set of 3x3 image. Like this, we are leaving this column, and then we are starting from this. We got feature like 3. We do for next round, we get 4. Next round, we get 2. Yeah. So now here it is start from second row. So for it is start going horizontally, and then once it finishes that all the column in one horizontal, then it start skipping one row. Like see, it is skip this row and it start convoluting like this. Okay. So likewise, it will move and it will generate the final set of feature. So now it has generated like 4, 3. So if I just explain in a very layman language, so 4 is have higher weightage than 3, okay, than 2. of course, right? So 4 is coming like diagonal. So somewhere like most important features of the images are lying somewhere in the diagonal. So that's what a basic interpretation you can do, very basic. Okay. So this is not the complete thing, just a basic interpretation, what I'm just trying to do you. Okay. So this is the working of filter. But have you observed one thing, the very important thing, while convoluting, what it has done? So what are the central values, right? So if you're following my mouse, I don't know if my mouse is visible. So just in middle part of the image, okay? So middle part of the matrix. So if you see those values, so filter has taken those values into consideration many times. Like see here, these values again came, then again came, but the corner values, this 1 0 0 1, these corner values are taken only once, right? But what happens in many times, corner has more important, useful information, right? So that's where we have certain different techniques which we apply over the filtering. Okay. So now, we'll come to that techniques. What filtering has basically done. So this I have just written down here. The weight matrix we have like a filter in an image extracting particular information from the original image matrix. So this you can read later. I have explained everything here. Okay. So now coming to the about the padding, that is the next important concept. So every time we apply a convolution operation, image size shrinks. Okay. And pixels present in the corner of the image are used only a few number of times during convolution, which I have already explained, right? You remember while convoluting, it is taking corner value only once, while the middle values multiple times, right? So that's the drawback, disadvantage. So that's where padding helps. So what padding will do, it will just add extra column, extra row to the surrounding of this image. Okay, so if you think this is the first row, then we'll add one more row here and we can keep all zeros. We can add one more column in the starting and having all zeros. Likewise, we can have one column in the end having all zeros. One row at the end having all zeros. So likewise, so this we have padded with one extra row and one extra column. So padding value will be 1. Okay. So what we are gonna achieve with this one? We are making sure the corner values also come many times so that their value is not lost. We are not deprioritizing them. We are giving equal weightage to them also, as well as the central values. So that's the whole concept. Okay. And then we have something called strided convolutions. Okay. So these like filter, padding, and third one is the strided. So these features comes under convolution layer. So what striding do? So sometime our image size is very huge. Okay, sometime or most of the times. Okay, what happens? So based to see, if you just go back here and you see, so if we have convolved this original image matrix with a 3x3 filters, we have got an output of 3x3. Okay, so don't get confused with like this will come equivalent to the filter size. This will be this may be different based on the this image size. Okay, so I have written the formula next slide. So formula you can apply directly, but important is to understand the concept. Okay, how this matrix is generated. So this is the final weighted matrix. Okay, so now, so what happens? So many times if image size is really too big, then what happens? We need to skip some rows or some columns. So that's what strided do. So here, if you see, first convolution happen in the very beginning of 3x3 matrix, but next convolution happens, it is not only skipping the first row, it is skipping 2 basically. Okay, so now it is starting the second round of convolution from here, right? So that will help you in reducing the size of the matrix. So this is what strided convolution do, and at the end we'll get the final set of features with the weights. And then, so that's all about the convolution layer. Then we have a pooling layer. What pooling do? It also helps you in reducing the size and hence speed up the computation. So what is this? So here also we start with certain filter, like suppose we have a 4x4 matrix as shown in the right side. and applying max cooling on this matrix will result in a 2x2 output. What is this all about? So if you remember in convolution, what we did, we multiplied, see, let me go there. So we multiplied all the digits, pixel value with the filter value, right? 1 cross 1 and 1 cross 0, then we added all. But here we are not going to do this. We will take the maximum of the feature. We are not adding, we'll take the maximum. So see here, same thing will happen. So here, so this is one filter convoluting, this is another filter, another one. So here, which is the maximum? 9. We are not summing up everything. It is the 9. Okay. Here it is 2. And the third quadrant, it is the 6. Okay. And then fourth quadrant, it is 3. Okay. So that's how these are the final weights. So pooling is the second layer. It also helps in reducing the size of the matrix. So this is all about pooling. So these are the formulas to come up with the final size of the matrix. So n cross n is nothing but the size of the original matrix, like number of rows into number of columns, and nc is nothing but the number of channels in the input. And here the filter size, again the number of channel in filter. This could be different. And then padding. What is the padding? If we have any padding, it could be 0, 1, 2, 3, anything. Striding, like how many jumps we want to make while convoluting. And then this will be the final size of the output matrix. And then NC dash is nothing but the number of filters. Okay. So this just the formula, but important is to understand the concept. Okay. So now this is the the last one is the output layer. So what this all about? So if you just concentrate before the green neurons, green circle boxes. Okay. So till here, it was all about the convolution and pooling layer. So we have multiple iteration of convolution and pooling layer, and after a different layer, we get the final set of feature. And in that one, if we apply some activation functions, so those activation functions are nothing but they help us to categorize them in a particular class. So in case of wafer, we can say like whether wafer is defective or not defective. Okay, so that's what. So once we apply the activation function, we get the classes, but it may not be the thing like in first iteration itself, we get the correct result. Then we again go back, we calculate the error, we go back, we feed forward those error, and we readjust that filters, we readjust the weights. So remember, I was talking about the hyper parameter. So for CNN architecture, this filter size, filter values, striding, padding, these all are the hyper parameters. Okay. So then we feed forward this and we again train, and then we do the classification. So this is all about the CNN architecture, how it works. So session wise, this is the last slide which I wanted to cover. And then, and of course, there are some future of semiconductors with respect to AI. So a lot of research is happening. So if I just let you know, like what is the normal duration of one chip designing, it takes around 5 to 6 months. Okay. Now you see, Google is claiming it can be done within 6 hours. See the impact. Okay. See, imagine. So you can read more about this paper later. So this is very interesting to read. So it is going to change everything in semiconductor industry if it is working with that much accuracy. Okay. So see the advancements are happening in this direction. So with this, I'm just concluding my session. So these are just my contact details. Like I also own, I write regular articles in my website. So you can just have a look on ashutoshtrepathi.com. And I also have like enetwork.ai, a platform where I provide a guided mentorship. So this is just like whenever I have some free time or over weekend, so people contact me. So I just provide. So this is all free of cost, no charges. And if people are interested to connect with me, they are most welcome. So I have my LinkedIn link, and of course you can connect with my Instagram. So I hope you guys enjoyed the session. So thank you very much for your patience and listening me carefully. So I hope it makes sense. So thank you.
Thank you, sir. I'm very sure everyone has enjoyed your session and learned a lot about machine learning, since machine learning is going to be used very much in the future. So, sir, are you okay with some questions they have posted on the chat box?
Yeah, please.
Yeah. Okay. Thank you, sir. The first question is, what is the difference between the functionality of deep learning and machine learning and its applications?
See, I already covered a bit of that one. See,
Yes, sir.
in machine learning, we have mostly structured data, okay, and of course the label data. So, so there are certain limitations. We cannot go beyond certain computation and certain size of the data, okay. And when we have a unstructured data like images, right, where CNN comes in place, where we have raw text, where NLP comes in place. So we need to train multiple layers. Okay, and one more important thing is like for deep learning, so they do feature engineering automatically. In machine learning, we have certain techniques like PCA, principal component analysis, or we can write our own customized method. We can come up, right? But in deep learning, it all is done by automatically because we have huge computation power. We can simply feed the raw text and deep learning will come up with the right set of features, right set of weights, which we can use for classification or predicting anything. But of course, I'm not telling deep learning. Deep learning is only the branch, a subset of machine learning. Okay, when we have raw text, we clean it, pre-process, make it for model training. Ultimately, we apply some of the ML algorithm only to classify, like logistic regression or neo-Bayes or anything, right? So ultimately, machine learning is used there also, but it has some advanced features. I hope it's clear. Yeah.
Yes, sir. Thank you so much. The next question is, how actually one of our professors has asked this question during the lockdown. How can ML help us take online examination or maybe improve the process of taking online examinations?
Okay, so if you talk about machine learning points, so I would tell like I'm already working in one of the applications. I will not reveal that one, okay, but similar direction I'm working. So what you can see, online examination. So see, there is one important use case, but maybe it is very advanced. But see, when we do the copy checking, okay, so there are certain biasness. I'm not telling an examiner is biased, okay, but certain kind of answer clicked his mind and certain another answer, though he's telling the same, he may not click, okay, so he will assign some more mark to particular kind of answer and not another answer. So there also we can build certain agents or robot where we can feed the scanned copy of the answer sheets and we can get the result quickly, very quickly and with more accuracy. Okay, so that's one area. I know this is very advanced, but of course we can think in that direction. So that is one area I could think of. And of course, with respect to online examination, so what I mean, can you please be more precise, like what you want to ask?
So actually, they have just asked that how can ML help us in taking online examination with a more precise approach? Basically, that is what they've asked.
Okay, so like see, so of course for online we need some video system. Okay, that's another thing, nothing to do with ML. But when we design the question paper, okay, so that time also see there is, I can think of there are a lot of improvements in that direction can happen. See. We can design the question paper in such a way which is most suited for the current trend, not only the theory and all those things. So we can have some intelligence which identify the trends going into the market, and based on that it can come up with some relevant questions and it can design the papers. So that's also one thing. I'm not telling our experts examiner cannot do this, but of course it is a time taking. If we have some ML intelligence behind some automated system, then of course they can quickly go through the market trend and they can also predict the upcoming trends, and based on that they can design the question paper. Even that can be helpful in training the students before the examination, right?
Okay, sir.
So that could be one thing.
Okay, sir. Thank you so much. The third question. Should I take a third one, sir?
Yeah,
Radhika, we can take a last question of the day and then
yes,
we'll conclude the session. Yeah, please.
Okay, sir. Yeah, sure, sir. So some students have asked that any courses or any specific domain which you would suggest doing courses or maybe some good future in the domain.
Okay. So see, this domain and courses all depends on the student's interest. Okay, so there are many cutting-edge technologies in today's world. Like one is AI, of course, one is IoT, of course, and there are in similar direction we are talking about augmented reality, right? So that's a more advanced version, and of course, in similar direction we have robotic process automation. Right. So these are the different cutting edge technology. So it all depends on which area students have interest. But of course, the next 20 years, I'm not thinking AI is gonna anywhere. Lot of potential is in
Yes,
AI.
sir.
If people study, then it's very good for their career. Lot of research potential are there.
Yes, sir. Sure. Thank you so much, sir.
Thank
And hope we have answered the questions. Of course, we could not take all the questions due to time constraint. But thank you so much, sir, Ashutosh sir, for your insightful session. And we as professors also learned a lot. Of course, the students would have learned much more. Thank you so much, sir. And I would take this opportunity to request Anand, sir, Mr. Anand Upadhyay, sir, Conclave Secretary, to give the vote of thanks.
Thank you, Radhika Madam. Good evening, everyone, and good evening, our respected Ashutosh Tripathi sir, who is a senior data scientist in the Infineon Technology, Bangalore, and our beloved Dr. Rajan Patil sir also. We are very thankful to him also that he has given his precious time and also graced our session. And I, on behalf of Thakur College of Science and Commerce, Principal, Management, HOD, we are very thankful to what Ashutosh Tripathi sir, even Rajan Patil sir, for coming here and enlightening us with the a very booming and very important concept of machine learning, how the machine learning is used in the semiconductor industries, what are the areas. And even though the Ashutosh Tripathi sir very well explained how the machine learning is, how he has used the machine learning to solve the real world problem in the semiconductor industry. Finally, I want to express my vote of thanks to my college management, principal, my HOD, my colleagues, my all technical, non-technical, supporting directly, indirectly, everyone. Once again, thankful everyone, and we will look forward once again for same cooperation and what involvement in the future. Thank you. Good evening, everyone. Thank you.
Thank you.
All the participants, tomorrow we'll have a session which will start at 11 o'clock. And still here, I request all of you to enroll and register for our session, which is based on the robotics process automation and various other sessions which are ahead. So you can see the brochure and you can enroll yourself. Thank you so much for all your cooperation. And again, here I'm repeating, as a conclave convener, session 1 certificate, as we have crossed the over limit, and then here session 1 certificate that will be available through an email mode. So don't worry about your session 1 certificate. Thank you so much for your cooperation.
Thank you, sir.
Thank you.
Thank you,
all.
Rajendra sir, for your presence here. Thank you, Ashutosh
Thank you
sir.
so much, everyone.
Thank you. Thank you.
Thank you, Vinit sir. Thank you, Ajgekar sir.
Thank you. Thank
Yes,
you. Thank
technical
you for,
host to end the session, please.
yeah, thank you to resource person as well as participants, sir. Thank you very much.
Thank you, sir. Thank you.
There is there.